Everyone, it's Mr. Spinelli. Today we're going to talk about finding the volume of pyramids and cones. And something I want you to notice about the formulas we'll be using is that they're similar to the volume for prisms and cylinders. There's just one little catch. Just a quick little review, the difference between a prism and a pyramid. Prisms, you can see that they have two bases and they're parallel to each other. For example, we've got this rectangular base here at the top and the bottom. This prism here, or cylinder, we've got a circle at the top and there's a circular shape at the bottom. But with the pyramid, you notice that all of the sides meet at a point opposite of the base. So when we're looking at pyramids and then at cones, notice that things meet at a point. So that's where the difference comes in. You have to be able to recognize these shapes so you know to use the proper formula. So the volume of a pyramid is very much the same as the volume of a prism, only you divide it by 3. So it's still the area of the base. So whatever this base shape is, you find the area using the particular formula, multiply by the height, which is the measured from the tip all the way down to the base. That height gets multiplied by the area, and you divide the result by 3. And again, we have the same exact equation for a cone, except remember a cone, we know the area of the base is pi r squared, where r is our radius of this circular base. So the cone and pyramid are very much the same, it's just we know the particular cross-section of a cone. So let's take a look at a few examples. So in this one, I've got a triangular pyramid because I've got a triangle at the base, and then all the sides meet at a point at the top. And then the base and height of this triangle are 8 and 15. So the area of my base is 8 times 15 divided by 2, which will be 60 meters squared. And then to get the volume, I have to multiply the area of the base times the height, which is 13, and divide that result by 3. So I'm going to take 60 times 13 and divide that result by 3, and I get 260 meters cubed. Again, volume is units cubed. It's a 3D object. The space occupied within that shape is units cubed. Let's take a look at another example. This time we've got a cone because the base is circular. So to find the area of that base, I need to compute pi r squared, and my radius happens to be 9. So I'll get 81 pi inches squared, which if you want to type that in your calculator, 81 times pi is approximately 254.47. Then I need to multiply by the height of 12. So volume is area of the base times height divided by 3. So I'm going to multiply the 81 pi times 12 and divide that result by 3. So if I type that in my calculator with pi, I will get 1017.88 inches cubed. Or if I want to keep pi in my answer, the exact answer is 324 pi inches cubed. And again, I would get the 324 pi by multiplying 81 by 12 and dividing that result by 3. And then just write the pi next to it. Next one, I again have a pyramid because everything comes to meet at a point. And it appears my base is rectangular, 15 by 7. So area of a rectangle is simply the base times the height, so 15 times 7. And then I'm going to do volume is going to be the 15 times 7 result, which is 105 centimeters squared. I'm going to take that area multiplied by the height of 20 centimeters, divide that result by 3, and I get 700 centimeters cubed. So here you can see where I'm actually analyzing the units. Centimeters squared times centimeter gives you centimeters cubed. So key thing you got to recognize is that height is always perpendicular to the base. Let's see if we can get a color to pop here. So that height is perpendicular to the base. It's the shortest distance from the base to the point. All right, so now we want to work backwards. And technically we could do this two different ways. So we want to find the height of the cone if the volume is known. So I'm going to write my volume equation. It's area times height divided by 3. More specifically, I know the area of this base, since it's circular, is pi r squared. So now I'm going to plug in everything I know. I know the volume on the left side of this equation that I've written is 1178.1. That has to equal pi times my radius squared. My radius is 15 because I have to take this 30 and divide it by 2. So square that. I don't know the height, and this all gets divided by 3. So now I'm going to do the inverse operation. So instead of dividing by 3, I'm going to multiply both sides by 3 to get rid of the division, and I end up with 3,534.3 equals pi. If I square 15, I get 225. So I really have 225 pi times h. So again, I multiplied both sides by 3 here. And now I want to divide both sides by 225 pi. And when I do that in my calculator, I want to make sure I put the 225 pi in parentheses. Otherwise, I will run into an error. And that is, I won't get the correct answer. So when I type that in, I get 5. So my height is equal to 5. And it rounds out pretty nicely to be almost exactly 5 centimeters. Okay, so we worked backwards using inverse operations from algebra. All right, we've got another cone. We've got to recognize that this dimension at the bottom is the diameter. So divide it by 2, so you get the radius is 10. Volume is equal to area of the base times height divided by 3. But we know the area of the base with a circle is pi r squared. So now I plug in everything I know. Radius is 10. Square it, multiply by the height, divide that result by 3. So in my brain, I do 24 divided by 3 is 8. And I know 10 squared is 100. So 8 times 100 is 800 pi. And my units are cubed. But if I want to type 800 pi in my calculator, it gives me approximately 2,513.27 centimeters cubed. So again, this is your exact answer. And this is an approximate answer to the nearest hundredth, or 2 places after the decimal. All right, so we've got a pyramid. It's not giving me this dimension over here, so I'm going to assume that it's square. I should see congruency marks, but we're just going to roll with it. So we've got a square base. So the area of that base is simply 16 squared, which is 256. And there's no units, so I'm just going to write u squared for units squared. So then my volume is area times height divided by 3. So I've got 256 times 24 divided by 3. And I should end up with 2,048 units cubed. All right, now we got a pentagonal pyramid, because the base is a pentagon, 5-sided shape, so I'm going to write number of sides is 5. I know the area of that is given by the apothem multiplied by the number of sides times, the side length times the side divided by 2. So the apothem is the 3 feet that was given. The side length is 5. The number of sides is 5. And I divide that result by 2. So I've got 3 times 5 times 5 divided by 2 gives me 37.5 feet squared. And then the height is given here as 73. So my volume is area times the height divided by 3. So I've got 37.5 times 73 all over 3. And when I type that in my calculator, I get 900. Whoa! I get 912.5 feet cubed. Again, remember that pyramids and cones, all the sides meet at a point on one end, and they meet at the base at the other end. So now I've got another working backwards problem. My goal is to find the height, and I'm given the volume. So I know that I can find the area of this particular rectangular pyramid. That area is just given by 8 times 3, which is 24 centimeters squared. So I know volume equals area of the base times height divided by 3. Plug in what I know. I know the volume on the left side is 56. I know the area of the base is 24. I do not know the height, and I have to divide that result by 3. Now there's two ways you can do this. You can do 24 divided by 3 on the right side and get 8. So you get 56 equals 8h. Or you could have multiplied by 3 and then divided by 24 on both sides, and you end up with the same result, and that is h equals 7 centimeters. All right, last one, trying to solve for the radius of the cone given the volume. So again, we know that volume of a cone is pi r squared, the area of the base, times the height, divided by 3. Plug in what we know. We know the volume is 1,102 and 79 hundredths. We do not know the radius, so I'm going to leave r squared in my answer. I know the height is 13, and I have to divide that result by 3. So I'm going to do this the long way. I'm going to multiply both sides by 3, and that gets rid of the 3 in the denominator on the right side, and that gives me 3,308.37 on the left. And then I've got 13 pi r squared on the right. Remember, I can reverse the order of multiplication. It goes in any order I want. So now I'm going to divide both sides by 13 pi, making sure to keep that 13 pi in parentheses on my calculator for the left side. And when I do that, I end up with approximately 81, and it's really 81.01 if you round, but if you don't round, you get almost 81 on the dot. So then to get rid of the square, I've got to square root both sides. So when I type the square root button, I should get approximately 9. And since my units are centimeters, my radius is in centimeters. Thank you for watching and have a wonderful day.